Okay, welcome back to the second part of this review. We are going to continue on with competencies uh, 4 and 5. So let's go ahead and get this ball rolling. Okay, competency 4 is a lot of words. There's a couple math problems, but it's a lot of words. Um, so they want to know, how does a distribution of a population compare, like what differences will you see when you create a sample? All right, so right now, okay, here's our regular old population kind of idea. So a population, kind of dull. And then, so we keep the same average, but when we create a sample, this is an over-exaggeration of what's going to happen. All right, this is what's going to happen when we create a sample. So what differences do I see? Well, I see that it's taller. So I see that samples have it's taller, so that'd be a larger relative frequency around the mean. And I see that it's more narrow, so that will be a smaller standard deviation. Remember that you have to mention both of them, and they're always going to be opposite of each other. Sorry, hard for me to talk at the same time. Okay, here is, you have to have a little bit of math involved with this. So what will happen to the sample distribution curve as the sample size decreases? So really the only thing that sticks out as far as mathematically is this formula right here. So if the n gets smaller, okay, what will happen? Well, this, because n is a division, if I divide by a small number, my answer is going to get larger. Okay, the smaller n gets, the larger the answer is going to get. This answer is a standard deviation. So by doing this, what am I seeing happening? Well, I see that I will have, in this case, a larger standard deviation. And so if that's larger, then that means I will have a smaller relative frequency around the mean. Okay, here comes the math problems. Number 17 is a regular x. Number 18 is an x bar. So in number 18, I'm just going to do the same thing, but with a new standard deviation. And we'll figure that out as we go along. All right, so number 17, we are, black ink. We are going to find the probability, aka the area, between 8 and 11. So to do that, we have to turn them into areas. So here we go, z-score of the 8. Make sure you round that number, and thus the area of 8 is the area associated with negative 1.31. So let's go ahead to our table of negative 1.31, 0.951. I totally forgot what it was. Yeah, 0.951. So I found the area of the small. Now I need to go ahead and find the area of the big and subtract the two. One straight up. So 1.008413. So the area, the probability in between the two would be the big area minus the small area. Okay. The next question is the exact same problem. We're finding the area between 8 and 11. However, the difference between this problem and the last problem is that this middle piece is an X bar. That means it's a sample. And so because it's a sample, we have to get a new standard deviation. Okay, so 5814 is our new standard deviation. So we go ahead and repeat the process. New standard deviation. Okay, so I developed that new standard deviation, found the areas of each. Now to find the probability, aka the area between the two things, I have to take the big area minus the small area. Okay, last but not least, why was the X bar greater than the X? Well, because X bar is a sample. What does that mean? Well, samples have a larger relative frequency among the mean. Oh, you actually just write this, I'm sorry. And it also has a smaller standard deviation. Okay, on to the very last competency, which is the R's get bars. R's get bars. What we need in here is we need a Q, which is 1 minus P. So if P is 0.35, that means Q is 0.65. What this helps us develop is our average and our standard deviation. So here our average is 0.25 and our standard deviation All right, let's draw a picture to understand the problem. So we're looking at 14, and we want our R to be is greater than 14 or is equal to 14. So that leaves the edge to be a little bit below the 14, so this is going to be 13.5 in this problem. Also, I noticed that the area is to the right, so this is going to be one of the problems that we have to subtract from 1. So I'm looking up 0.44. So 0.44 is 67 on the nose. Again, that is the area to the left. That's the area that I don't want. So in this situation, what I have to do is take my resultant area away from 1. So it's going to be 1 minus 0.6700. Math class has shown that 83% of the students are in attendance. Mr. Novak has 31 students in his class, wants to know that the number of students in attendance is less than or equal to 23. Okay, here we want to know that the R is less than, it's kind of new, or equal to 23. So that leaves the edge right here, which is a little bit above the 23. So we are operating with 23.5. When I do find this area, it will be the area to the left, which is exactly what I want. So I am not going to subtract this from 1. Again, make sure you round to 2 decimal places. Negative 1.07 in this problem. Negative 1.07. Notice that is the area to the left. That is what I wanted. Sorry. One more time. All right, whatever. I'm going to shrink some more stuff than I really wanted to, but you get the idea. All right, so for problems 22, 23, and 24, they have the same n and the p, so that means they're going to have the same average and the same standard deviation. So all I have to do is figure it out once, and then I have it for all 3 of them. So I will go to work on 22. So because 1 minus p is the q, this would be 0.88. That means the average symbol. The average is equal to n times p. And standard deviation is n times p times q square rooted. Okay, so as I said, I have this established, so I can go ahead and steal my average and standard deviation for the rest of the problems. Okay, so this question is asking me R is less than 60. And I'm going to jump down over here. This is also bringing up 60. Okay, so the difference between these two things are this. Number 22, they want R to be is less than 60. So this is the shading in that situation. In number 23, they want R to be is less than 60, so it's the same thing. However, in this one, it is also or equal to, so that means it involves. So up above, the edge exists right here, which would be at 59.5. And this problem, its edge exists right there, which is at 60.5. So that is the difference. So let's go to 22. X, Z, area. Okay, so we have the X, we need to find the area. And then when I find this area, it'll be the area to the left, which is exactly what I want. So I don't have to subtract it from 1. It is what it is. So here we go. Z of 59. answer. That is the area to the left. That is exactly what I wanted. So that's my answer. Three. Again, when I find this area, it'll be the area to the left, which is exactly what I want. So I do not have to subtract from 1. That is the area to the left, so that's exactly what I wanted. All right, the very last question, we are finding the area in between 40 and 60. So we have this 40, we have this 60. So again, ours get bars. So we're finding the area in between the two things. In this particular problem, we want it or equal to the 40. Okay, so that portion says or equal to 40. And then on the 60 side, it is also or equal to. So the 60 also gets the shading of the bar. So in this problem, I see that the edge exists right here and right here. So the low one is a little bit below the 40, so that's 39.5. And the upper one is a little bit above the 60, so that's going to be 60.5. So in this situation that we have the same average and the same standard deviation, I know information about the 60.5. I figured it in the previous problem. So this will have a z-score of 1.42 and an area of 0.9222. Okay, so that kind of saves us some time here. And all I need to do is find the z and the area of the 39.5, and then I can find the difference between the two things. So 39.5 is my main focus right now. Okay, so this is ultimately asking what is the area in between these two things. So when I find the areas to the left, which I'm supposed to, all I need to do is find the area of the big and subtract the area of the small. That'll be the area in between the two. So in this particular problem, the area of the big is 9222. Area of the small is 0427. And that's the area in between. Okay, that completes this test. And yeah, that's it.